Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 1.3.2, which is angles formed by transversals. Not a particularly mathematically driven chapter, but a lot more terminology driven. The first thing we're going to do is we are going to establish the meaning of these symbols right here. This symbol and this symbol, the two arrows. Whenever you see these two arrows in succession like that across two lines, what it means is that the two lines are parallel. Parallel meaning they have the same slope, which means they will never intersect each other. So keep that in mind. When you see those two arrows like that, you can assume parallel between those two lines. The next thing is the transversal, which they describe up here. They call it a line that crosses two or more lines. They call that a transversal. So they say in Julia's diagram, which is the one we're looking at on the right side here, which line is the transversal? Well, that would be line JK, right? So line JK. So line JK is the transversal. So the transversal. Which lines are parallel? We can say that LM is parallel. This is the shorthand for parallel. Line LM is parallel to line NP. And there we go. That's how we define things being parallel, things being transversals. Now, when a transversal cuts through parallel lines, a very special relationship is created. They're asking you to trace angle X and blah, blah, blah. So this one here, you're supposed to use patty paper and trace angle X, and then you're going to slide that angle on top of another one. So you're going to slide angle X. I'm going to go and highlight this thing in blue. You're supposed to slide angle X on top of angle B. By doing so, what you'll find is that angle X will be, now this symbol right here means congruent. If I can spell that, congruent. Now, again, you're using patty paper for this, but you'll find that it will be congruent to angle B. In other words, they will have the same angle measure. Those two angles are known as corresponding angles. Corresponding angles, and they define it right here, corresponding angles are angles in the same position, but at two different intersections of the transversal. So, I always say corresponding means same position, but different location. An analogy that people can really think about that might make this easier is if you look at any kind of sports team, football for example, every team has a quarterback, which means each quarterback is in its own corresponding position, right? And so one quarterback for one team, one quarterback for another team, they are in corresponding positions because they're both quarterbacks but in different places. And so yeah, that's what corresponding angles mean. And for here, one thing we want to know, and you will get a resource page, a graphic organizer for this, but basically it says if the lines are parallel, then the corresponding angles will be congruent. Now, in the beginnings of Integrated 2, there's a lot of C words that deal with angles. You learned corresponding just now. You've learned congruent for a while. You learned complementary in the last section. So keep those C words separate, right? Congruent means the same. Corresponding means same position but different location. And complementary means summing up to 90 degrees. And so just make sure you keep those separate and keep those compartmentalized because it's easy to get those terms mixed up. And so that deals with the corresponding angles. Now from here, not only are B and X corresponding, but if you did the patty paper, you would see that C and Y are also corresponding, W and A are also corresponding, and D and Z are corresponding, meaning all of those angles are going to be congruent. So angle A is going to be congruent to angle W. Angle C is going to be congruent to angle Y. Angle D is going to be congruent to angle Z. And you're going to see, which one did I miss? Angle B is going to be congruent to angle X. We talked about that already. And again, these are all corresponding. I'll go and write it down here. That way it contrasts the black background. Corresponding corresponding angles. And this 3 dots here in the triangular formation means the word therefore. And so it means therefore congruent, because the lines are parallel. Now, I'm going to ask you as a true-false question in just a... Oops, that doesn't mean congruent, that means therefore. Thinking too fast. And so I'm going to ask you as a question in just a second with the next diagram. Give me a second. I apologize, I got a little ahead of myself. That was the next section, so I'll ask you guys that true-false question in just a second. They want us to say that suppose angle B is 60 degrees, so this is 60 degrees. Now we have to determine all the other angles in Julia's diagram. Well, we just established that the corresponding angles were going to be congruent, and so I can say then that angle X is 60, okay? And then from here, using our linear pair relationship, I can say that angle A is going to be 180 minus 60. Remember from the last section, right? Linear pairs always sum to 180. So I can say then that angle A plus 60 is equal to 180. And I apologize if that's a little hard to see. Maybe get into a dark room. This is going to be 120. Now, from here, I can go ahead and call this angle W 120 as well. So from here, that takes care of the linear pair relationships, but remember, we also learned another angular relationship in the last section. We learned that vertical angles are also congruent. So if angle X is 60, that means that angle Y has also got to be 60, and angle C has also got to be 60, again, based off of that vertical angle relationship. Vertical angles are when you have opposite angles when two lines intersect each other. Now, there are a couple of ways you can go about getting angles D and Z. One, you can actually say, hey, look, the angle D is vertical to the 120, making it 120 because vertical angles are congruent. Or you could say, hey, look, I've got this angle here 60, and Z is a linear pair to the 60. Either way you cut it, angle Z has got to be 120. So you see how there's multiple ways to get to the same answer in this particular section, which is great. I'm all about that level of choice. Okay, so now I'm going to ask you that true-false question, and go ahead and ponder this while I go find the next portion of the handout. The corresponding angles of parallel lines are going to be congruent when they are cut by a transversal. Okay, so corresponding angles of parallel lines are congruent. Here's the true-false question before I pause. All pairs of lines are parallel. Think about that. Is that true or is that false? I'm going to pause this for a second. I want you to do the same thing. All pairs of lines are parallel. Is that true or false? I'll be back in a flash. And we are back, and if you took the time to pause and ponder the question that was true-false, you should have gotten a definitive false, right? Not all pairs of lines are parallel. In fact, most of the time they're not, right? And so that doesn't mean that they can't have corresponding angles, though. And so in this case, if you look at, well, we'll talk about that with B, but from here, it says, so far you've investigated transversal lines that cross pairs of parallel lines. However, they can cross any parallel lines. So Frank wonders whether or not the corresponding angles are always congruent, and we're going to find out if they are or not. Now remember, look at the arrows here. The arrows here indicate parallelness. So that means that we are being cut by a transversal, which means we've got some congruent angles here. Angle X has got to be 135 because he's corresponding with the other 135. Y is vertical to X. Remember that term right there again, vertical angles. Another 135, again, because vertical angles are congruent to each other. In B, those lines are absolutely not parallel. The one line's going this way, one line's going that way. They will inevitably intersect each other, which means even though 135 and X are in corresponding positions, because the lines are not parallel, this X is not 135 degrees. Let's make sure we make that clear. Having said that, we can solve for the Y here because they are, in fact, a linear pair. So 180 minus 35, I believe Y is going to be 45 degrees. X is going to be, well, I don't know what that is because we don't have enough information, but I do know what he's not. He's definitely not 135. So again, here we go. Parallel lines in C, 135 and X. So because they are in corresponding position, we have parallel lines. We got 135 degrees here. Y is a linear pair to the X, which means he's got to be 45 degrees. Got to be 45 degrees. Remember, that linear pair adds up to 180 degrees. In D, well, 135 and Y, well, those are what we call same side exterior angles, but we'll talk about more about that in the next section. They don't have a relationship to each other, at least right now, because the lines are absolutely not parallel, but I believe these do form a linear pair, so I think X is going to be 45 degrees. So I think that will pretty much wrap up this lesson about transversals and angles created by them. The biggest takeaway that I want you all to get from this is that if the lines are parallel and cut by a transversal, then the corresponding angles will be congruent. Now remember, this rests heavily on the notion that the lines are parallel. As we saw in the last example, when the lines aren't parallel, they can still be cut by a transversal and the corresponding angles don't necessarily have to be congruent. But if the lines are parallel, remember, parallel indicated by this symbol right here, right? A line with those two lines with those two symbols means that they're parallel. If they're cut by a transversal, you got corresponding angles all over the place. Those corresponding angles will be congruent. And we'll do an angle summary of this when we hit all of the types of angles created by a transversal with parallel lines. So that shall wrap up this lesson. As always, feel free to leave questions in the comments area and we will take care of them in class. I will see you in the next episode.